Dear students, welcome back to a new mathematics session. In the previous session, we have discussed first 11 questions from the miscellaneous exercise of chapter 7 integrals. Hope it was clear for you all. In today's session, we shall discuss the remaining problems from the same exercise. Let's move on to the topic. Before starting the session, let's recall the properties of definite integrals. The first property is integral a to b f of x dx is equal to integral a to b f of t dt. Here the variable of the function is not a matter if the limits are same. Means the upper limit and lower limits are same. Here integral a to b f of x dx is equal to integral a to b f of t dt. When you check here, the lower limit is a and the upper limit is b. Here also the same thing, the lower limit is a and the upper limit is b. In the first case, LHS part the function in terms of x, and the second on the right hand side the function is in terms of t. So this is the first property, integral a to b f of x dx is equal to integral b to a f of t dt. The second property is integral a to b f of x dx is equal to minus of integral b to a f of x dx. Here what we have done is just we have interchanged the limits. First of all, in the LHS part it is a to b, and in the RHS part it is b to a, provided there is a minus sign. So the second property is integral a to b f of x dx is equal to minus of integral b to a f of x dx. Here there is a particular case also. Here integral a to a f of x dx is equal to 0, means the upper limit and the lower limits are same, means the integration of that particular function value is 0. Then the third property is integral a to b f of x dx is equal to, we can split the limits, integral a to c f of x dx plus integral c to b f of x dx. Here a to b we are splitting as a to c and c to b. This is the third property. And the fourth one is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. What we have to do is the upper limit and lower limit we have to add, and we have to subtract the variable. So a plus b minus x, integral a to b f of a plus b minus x dx. And the next property is integral 0 to a f of x dx is equal to, here the lower limit is 0 and the upper limit is a. So integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, means upper limit you have to take and minus it with the variable. So f of a minus x dx. The next property is integral 0 to 2a. The previous property was integral 0 to a, and here the limit is 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So this is the way we have to split the integrals, means integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. These type of properties, when we apply it in the problems, it will be more clear for you. Then the next property is integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x, and integral 0 to a f of x dx will be equal to 0 if f of 2a minus x is equal to minus of f of x. So first of all you have to find out f of 2a minus x, means this upper limit you have to take. F of 2a minus x, if you get as f of x, then the integration can be done by using 2 into integral 0 to f of x dx. Then if you find out f of 2a minus x, and if you get as minus of f of x, then we can write the integral value as 0. Then the last property, that is integral minus a to a. So this is the first property by using negative and positive upper and lower limits. Integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f is an even function. How do we check the function is even or not? This is the way. If f of minus x is equal to f of x we get, then we can say that it is an even function. Once it is an even function, we can write as 2 into integral 0 to a f of x dx. And if it is an odd function means if you find f of minus x, you should get minus f of x. We have discussed some example in the previous class. So this will be useful to solve such type of questions. The second property is minus a to a f of x dx will be equal to 0 if f of x is an odd function. So before proceeding to the next session or the next problems, we have to make sure that you are very familiar with these properties. Altogether 8 properties are there, starting from 0 to 7. Move on to the exercise problems. Using properties of definite integrals, evaluate the following integrals in exercises 12 to 18. Question number 12, integral 0 to pi x dx divided by 1 plus sin x. This is our question. So let's take this one as I is equal to integral 0 to pi x divided by 1 plus sin x dx. Label it as equation number 1. Then when you check the limit here, it is from 0 to pi. The property we are going to use is integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. So here integral 0 to a, that format it is. So 0 to a f of x dx is equal to 0 to a f of a minus x dx. So here a upper limit is pi and the variable is x. So that will be coming as I is equal to integral 0 to pi. X is replaced and substitute pi minus x. So pi minus x divided by 1 plus sin pi minus x. Label it as equation number 2. Here little calculation work also, if you can do it. If you want one more step you can write, but I'm not writing that one. Sin pi minus x is sin x. Okay, so that we will do while doing the calculation. Now as per the algorithm, it is equation number 1 and 2 we have to add. So equation number 1 and 2, when we add, I plus I will be getting 2i is equal to 0 to pi is common in these two. So integral 0 to pi, first term is x by 1 plus sin x as it is, plus pi minus x divided by 1 plus sin pi minus x is sin x. So pi minus x by 1 plus sin x dx. Now when we check here in the denominator, same for both fractions. So if the denominators are same, just add the numerators. That is integral 0 to pi. Denominator is same, 1 plus sin x. The numerator is x plus pi minus x. So when you check here, there is numerator x and minus x we can cancel. So the balance will be pi is a constant, keep it outside, integral 0 to pi, numerator nothing is balanced, so 1 we can write divided by 1 plus sin x dx. So this is 2i. So from here I we can calculate. When we calculate I, this 2 will be coming to the denominator here, that will be pi by 2. Then that step I am not writing, just that we will do it along with the next step. Here 1 by 1 plus sin x is not in our known format, so again we have to change this one. So 1 plus sin x conjugate is 1 minus sin x. So just take and multiply in the numerator and denominator. So it will be coming as I is equal to pi by 2. Here pi by 2 how comes, in the sense this 2 is coming to the denominator here. So pi by 2 into 0 to pi 1 by 1 plus sin x as it is. Then take the conjugate and multiply it in the numerator and the denominator. 1 minus sin x by 1 minus sin x. Then I is equal to pi by 2 into integral 0 to pi 1 plus sin x into 1 minus sin x, that is a plus b into a minus b format. A plus b into a minus b formula is a square minus b square. Then numerator 1 into 1 minus sin x, that is 1 minus sin x. Then I is equal to pi by 2 into integral 0 to pi, numerator same 1 minus sin x by 1 minus sin square x formula we know, that is cos square x. Then what we can do is just split it, this one somewhat it is known to us when we split, because we have done this type of calculation before also. When we split, we will be able to do the integration easily. So pi by 2 into integral 0 to pi 1 by cos square x minus sin x by cos square x dx. Then I is equal to pi by 2 into integral 0 to pi 1 by cos square x is sec square x minus, here denominator there are 2 cos x's are there, that is one is cos x into cos x we can write. So sin x divided by cos x into cos x. Then pi by 2 into integral 0 to pi sec square x minus 1 sin x in the numerator and 1 cos x in the denominator. So sin x by cos x, when we combine we will get tan x divided into, here there is numerator nothing is balanced because only 1 sin x was there that we have taken for making tan x. So there is only one balance, 1 by cos x is sec x dx. Then these two integration formulas we know, so directly we can go for integration. Pi by 2 into, there is a bracket we have to keep, into Then integral of sec square x. Integral of sec square x is tan x. Then we have to write the upper limit and lower limit 0 to pi minus integral of tan x sec x or sec x tan x. That is sec x. Limit we have to write. Apply the limit here, pi by 2 into tan upper limit tan pi minus tan 0 minus here sec pi minus sec 0. We have applied the limits here. That is pi by 2 into tan pi value is 0, tan 0 value is also 0, minus sec pi is here minus 1 and minus sec 0 is 1. So sec pi means this value we should know that. If you don't know, just write and keep sec pi value is minus 1. So here when you do first bracket fully, it is going 0 minus 0 is 0 and only the second bracket is there, that is minus 1 is minus 2. So pi by 2 into 0 minus 2, minus 2 is plus 2. So pi by 2 into 2, these two are, both the 2's in the numerator and denominator can be cancelled. So the answer will be pi. So the answer for question number 12 is pi. Move on to the 13th question. Integral minus pi by 2 to pi by 2 sine power 7 x dx. So here when we check the limit, it is minus pi by 2 to pi by 2. That means when we compare with our properties, 7 properties, it is from minus a to a. If minus a to a limit comes, means there is a property we have studied, that is minus a to a f of x dx, means the values will come based upon the function. If the function is even, then it is 2 into 0 to a f of x dx. The function is odd, it is 0. Okay, so first of all we have to check whether sine power 7x is odd or even function. For that, let's take that one, f of x is equal to sine power 7 x. For checking whether it is odd or even function, we have to first calculate f of minus x. If minus x, f of minus x, if you get as f of x, then it is even function. If f of minus x is coming minus f of x, then it is odd function. So here let's calculate f of minus x. That is sine power 7 x is replaced with a minus x. So this one little bit of arrangement we can do. Sine of minus x, that is minus sine x. And this power 7 we can just keep outside. Minus sine x the whole power 7. So here minus of something, the power is or the exponent is odd number. So exponent odd number means minus sign will be coming. So it is minus sine x. Sorry, minus sine power 7x. So minus sine power 7x means it is minus sine power 7 is f of x. So minus f of x we have got. Once again, sine power 7 of minus x we have calculated. Then this 7 we are just keeping outside the bracket, that is sine of minus x the whole power 7. Sorry, minus sine x the whole power 7. And since the power is odd, we can just write it as minus sine power 7x. It's not, there is no change in the sign since the exponent is an odd number. So sine power 7x is f of x. Then it will be minus f of x. So f of minus x we have got as minus f of x. That means it is an odd function. If it is an odd function, means the integral value we can write directly as 0. That means f of x is an odd function of x. Integral minus pi by 2 to pi by 2 sine power 7x dx is equal to 0. Directly we can write the answer. Next we shall discuss the 14th question. Integral 0 to 2 pi cos power 5 dx. So here first of all we have to identify the property. Here 0 to 2 pi means it is in the form 0 to 2a. Integral 0 to 2a f of x dx. So the property is integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Here you see 2a is the upper limit. Half of that limit will be coming here as upper limit. So here 2 pi is the upper limit. So half of 2 pi is pi. So that you have to keep in mind. Here 0 to 2a f of x dx means that will be splitting as integral 0 to a f of x dx plus integral 0 to f of 2a minus x dx. So here whatever is there in the upper limit in the question, when we split it we will take the half. Okay. So here 2 pi is there, 2 pi half is pi. So that what we are going to do is integral 0 to pi. So 2 pi half is pi. 0 to pi cos power 5 x dx plus again same thing only 0 to a only here also. So integral 0 to pi cos power 5 into 2a minus x. 2a minus x means this limit fully we are taking. That means here limit is 2 pi. So cos power 5 2 pi minus x dx. So here we know that cos 2 pi minus theta is cos 2 theta. So the same thing will be coming. So just we can write it cos power integral 0 to pi cos power 5x dx plus integral 0 to pi here cos power 5 2 pi minus x is cos power 5x. So that we have written by using this formula. Now when we check, these two terms are same terms. Okay, the one integral 0 to pi cos power 5x dx plus 1 integral 0 to pi cos power 5 dx. So 1 plus 1 is 2. So 2 into integral 0 to pi cos power 5 dx. Then here 2, that is a common term, just we can keep it. Then apply again this one we can use it another property here, integral 0 to a f of x dx. So sorry, this same property we can apply, that is better. So integral 0 to 2a f of x dx, that same property we can apply. Just to keep in mind that here instead of 2a there is only pi is there. So when we take the limit here, half of that we have to take. So here the limit is pi. So what we have done is half of pi, that is pi by 2 will be taken. So integral 0 to pi by 2 cos power 5x dx plus integral 0 to pi by 2 cos, same limit. What is there here? The same limit will be taken, 2a minus x dx. Same limit is here, pi. So cos pi minus x dx. So we applied the same property 2 times. Okay, so first part we have applied here, little work we have done, and again just for further simplification using the property one more time, 2 times we have used. Okay, if you have a doubt then just write it on the right side of this step, the same property here. Then here cos pi minus x, cos pi minus theta is minus cos theta. So cos pi minus theta, it is coming in the second quadrant. So second quadrant cos is minus, so minus cos theta will be coming. So 2 into integral 0 to pi by 2 cos power 5x dx plus 0 to pi by 2 cos pi minus x is minus cos x the whole power 5 dx. Then 2 into integral 0 to pi by 2 cos power 5x dx minus, then this plus into minus, minus 0 to pi by 2 cos power 5x dx. Then 2 into, here when we check the same quantity with a different sign. So here 0 to pi by 2 cos power 5 dx minus 0 to pi by 2 cos power 5x dx. So both will be cancelled and we are getting the answer as 0. So 2 into 0, that is equal to 0. That is the answer for the 14th question. Next we shall discuss the 15th question, integral 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x. So here integral 0 to pi by 2. So the better we can use it as integral 0 to a property. Okay, the property is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So this is quite familiar property. We have solved several questions. We know the algorithm also. Let the given integration we have, what we have to do, let it be I is equal to integral 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x dx. Well, it as equation number 1. Then apply the property. That means f of a minus x we have to put, changing x to pi minus 2 minus x in integrand of 1. So it's not necessary to write, just directly we can write also, it's not a problem. That's what we have done in the previous questions. So I is equal to integral 0 to pi by 2 a minus x. So a is here pi by 2 minus x. So sin of pi by 2 minus x minus cos of pi by 2 minus x divided by 1 plus sin of pi by 2 minus x cos of pi by 2 minus x. So integral 0 to pi by 2 sin 90 minus x or pi by 2 minus x is cos x minus cos pi by 2 minus x is sin x divided by 1 plus, here this will be changed to cos x, this will be changed to sin x. Label it as equation number 2. That is I is equal to, what we have to do is here cos x minus sin x. Cos x minus sin x is there. Previous equation number 1, it is in sin x minus cos x format. So when we take a common factor of minus 1, it will be easy for you to do the calculation. So that's what we have done here, minus of integral 0 to pi by 2. Here minus sin x is there, that minus coming out means plus sin x will be coming. Here plus cos x is there, then from there we have taken a minus sign outside, means 1 minus balance, so minus cos x will be coming divided by 1 plus sin x cos x. What we have done is taking a minus sign from the numerator. Label it as equation number 2. As before, add equation number 1 and 2. 2i is equal to, you can see here, in equation number 1, integral 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x dx. And in equation number 2, minus integral 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x. Same quantity with opposite signs. Directly we can write it as 0. So 2i is equal to 0, then I is equal to 0. This is the answer. Next we shall discuss the 16th question. Before start solving this question, I just want to tell you that this is one of the lengthiest question in this exercise, and please be mentally prepared for solving this question. And there are several properties we will be using throughout the question. And before start solving, just pause it in 2-3 different places and then just recall it and try to complete it. And after completing, just try to solve by your own one more time. Okay. So integral 0 to pi log 1 plus cos x dx. So here integral 0 to pi means it is in the form 0 to a. So that property we are going to use. Integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. That's what we are going to use. First of all, let's take this one as I and label it as equation number 1. Then apply the property I is equal to integral 0 to pi log 1 plus cos x. So x is replaced and substituted as a minus x. What is a here? Pi. So pi minus x dx. So cos pi minus x. Cos pi minus x, we know that is minus cos x. So pi is 180. So pi minus x is coming in second quadrant. So here second quadrant cos will be minus. So 1 minus cos x will be coming. So integral 0 to pi log 1 minus cos x dx, label it as equation number 2. So we have two equations. What we can do as per the algorithm, just we add it, equation number 1 and 2. While adding I plus I, that is equal to 2i equal to integral 0 to pi, common we can take in both. First part log 1 plus cos x as it is, plus log 1 minus cos x dx. Then integral 0 to pi log 1 plus cos x into 1 minus cos x. This is in the form log a plus log b dx. So log a plus log b is log a into b. So log a is 1 plus cos x into b is 1 minus cos x dx. If you don't know the property, write here and keep. Okay. Then integral 0 to pi log a plus b into a minus b. A plus b into a minus b is a square minus b square. So 1 square is 1 minus cos square x is cos x the whole square is cos square x. So now we know 1 minus cos square x, that is integral 0 to pi log sin square x dx. So 2i is equal to integral 0 to pi log sin square x dx. Then here log sin square x, what we can do, log x power n, that is n log or log m power n is equal to n log m, that is the format. So this 2 will be writing here as a constant. Log m power n is equal to n log m. Write the property if you want. So 2 is a constant, so just to keep it outside, integral 0 to pi log sin x. So this power came here. Okay. Then 2 into integral 0 to pi log sin x dx. Now the property we have used is this one. Okay. From here I we can calculate. I is equal to here 2, here also 2. Left hand side and right hand side same constants, we can cancel it. Then integral 0 to pi log sin x dx. So we have applied the property one time, but still we didn't reach in the proper format. So what we can do is we have to do again this calculation further. Okay, further we have to move. So now we have got I is equal to integral 0 to pi log sin x dx. So this one, it is not in our non-format. Again we have to go for applying the property and going for finding out the integration according to our non-format. So first of all we have to bring this one to our non-format. This one first thing we have to do. But when we check the upper limit and lower limit, it is from 0 to pi, but the same 0 to a f of x dx, that it is not necessary to apply here. We have one more property we have learned, that is P6, that is 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx. This is a property we are going to use. Okay. Integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx. There are some certain conditions are there, provided f of 2a minus x is equal to f of x. So here when we check 2a, here instead of 2a we are having pi. So here f of pi minus x, when we put, it should come f of x. So let's check. So here f of x is equal to log sin x is there, then log sin x. Then what we can do is f of pi minus x, means here 0 to 2a, that property we have to take, we are going to use. That means f of 2a minus x we have to check. So here the upper limit, when we check, instead of 2a, pi is there, so we have to substitute pi minus x instead of x. So log sin pi minus x, that is equal to log sin pi minus x is sin x. So log sin x is coming. What is log sin x? That is f of x. So the property is satisfied here. F of pi minus x is equal to f of x. The condition is satisfied. So we can directly write 2 into integral 0 to a f of x dx. So 2 into integral 0 to a means here the upper limit is 2a. Here the upper limit is a. That means half of 2a. According to our question, the upper limit is pi. So when we take half, pi by 2 will be coming. So the property we have used is, we are going to use is this one. That is I is equal to 2 into integral 0 to a means half of 2a, that is a. So 0 to pi by 2 f of x dx, that is log sin x dx. Only thing is that what we have changed is the limit we have changed 0 to pi by 2, and here there is a 2k. Okay, then label it as equation number 3. Now what we have to do is, again the first property we have used, that we have to apply here. That is integral 0 to a f of x dx, that is equal to integral 0 to a f of a minus x dx. That is the formula property we are going to apply here once again. That is I is equal to 2 into integral 0 to pi by 2 log sin x should be replaced and substitute a minus x, that is pi by 2 minus x dx. Same property. First what we applied, the same property, this one. That is I is equal to 2 into integral 0 to pi by 2 log sin pi by 2 minus x is cos x dx. Now we can just mark it as equation number 4. Actually this part we are doing like a single question. Okay, so previously we used to mark this one as equation number 1 and equation number 2, then we add 1 and 2. The same procedure will be following. So here equation number 3 and 4, what we do is adding equation number 3 and 4. So I plus I, that is 2i is equal to, here 2 is common, just to keep it outside, 0 to pi by 2 log sin x plus 0 to pi by 2 log cos x. This is in the form log a plus log b, that is log a plus log b is log a into b, that is 0 to pi by 2 log sin x into cos x. Okay, log a plus log b is log a into b, that is sin x into cos x dx. Here there is a 2, here also there is 1 2. On the right hand side and left hand side, both we can cancel it. These 2 and these 2 we can cancel. So I is equal to integral 0 to pi by 2 log sin x cos x dx. Then this is in the form 2 sin theta cos theta format, sin 2 theta form. Okay, so what we need is, here 1 2 is necessary. So what we do, just put 1 2 here and divide another 2 in the denominator. So 0 to pi by 2 log 2 sin x cos x divided by 2 dx. We know that 2 sin x cos x is sin 2x. So 0 to pi by 2 log sin 2x by 2 dx. Then I is equal to integral 0 to pi by 2. Apply the logarithmic rule, that is log a by b. Log a by b is log a minus log b, that is log sin 2x minus log 2 dx. Then I is equal to, just we'll do the integration, that is 0 to pi by 2 log sin 2x dx minus 0 to pi by 2 log 2 dx. Again this is not in our non format, but this one is in the non format. So we can do this calculation. This one we can do one more time. That is integral 0 to pi by 2 log sin 2x dx minus log 2 is a constant, integral 1 dx is x. So upper limit and lower limit is there. The first part we will just keep it for another calculation. Just keep as it is, 0 to pi by 2 log sin 2x dx minus pi by 2 into. So here pi by 2 into log 2, how we have got in the sense x, we have to substitute upper limit minus lower limit. So pi by 2 minus 0. Pi by 2 minus 0 is pi by 2. So pi by 2 into log 2 is the balance. Then this one again we need to do the integration. So what we can do, this one we can write it as I is equal to another integration we are going to do. So this one we can consider as I1 minus pi by 2 log 2. Mark it as equation number 5. And where I1, just we have removed this one and put I1. So I1 is equal to integral 0 to pi by 2 log sin 2x dx, this quantity. So this integration again we will do. And again we will come back to equation number 5 and we will substitute. That is what we are going to do here. Next we will do the I1 part. I1 is equal to integral 0 to pi by 2 log sin 2x dx. This one we will do by using substitution method. We have to change this 2x. So 2x as t. Put 2x as t. Derivative when we take 2 is equal to dt by dx. Then 2 dx is equal to dt. We need a dx value. Dx is equal to dt by 2. So since it is substitution method, the limits also we have to change. When x is equal to lower limit is 0. When x is equal to 0, t is equal to 2 into 0. That is equal to 0. When x is equal to pi by 2, t is equal to 2 into pi by 2. 2 into pi by 2 means 2 to cancel. We will be getting as pi. Then I1 is equal to 0 to pi by 2 changed as 0 to pi. 0 to pi log sine 2x replaced as t. Log sine t into dx changed as dt by 2. That is 1 by 2 into integral 0 to pi. This 2 we can take outside. 1 by 2 into integral 0 to pi log sine t dt. Now this one again we are going to apply property, that is here as we know that it is sine is there, so f of 2a minus x property we can use. So log f of x is equal to log sine x, then f of pi minus x. F of pi minus x, if you calculate log sine pi minus x, previously we have done in the same question itself. That is equal to log sine x. Log sine x means f of x, that is equal to f of x. So if f of 2a minus x is equal to f of x, then 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx. Previous slide we have discussed in the same question itself. We have applied this property one time. So 0 to 2a f of x dx is equal to 2 into integral 0 to a, in this half of this one, 0 to a f of x dx. So what we have to do is 1 by 2 into this one we can change to 2 into, so 2 into 0 to a means half of this value, original upper limit. So half of original upper limit is pi by 2. So 0 to pi by 2 log sine t dt. Only thing is that in this we are changing only the limits and this constant. Okay? 2 into 0 to pi by 2 log sine t dt. Here these two, both the two numerator and denominator can be cancelled. So I is equal to 0 to pi by 2 log sine t dt. That is equal to 0 to pi by 2 log sine x dx. So here we are changing the variable. This property also we have learned. If the limits are same and if the variable is changed, it's not a problem. So here 0 to pi by 2 log sine t dt, we can write it as 0 to pi by 2 log sine x dx. So this is the property we have used. Integral a to b f of t dt is equal to integral a to b f of x dx. Then I1 is equal to, this is actually something we can relate it with I. So I is equal to, what we have got is I is equal to 2 into integral 0 to pi by 2 log sine x dx. Here we are having 0 to pi by 2 log sine x only. That means 0 to pi by 2 log sine x we want. These two we can bring down. That means I by 2. That's what it is written. I1 is equal to I by 2 it is written. So by equation number 3 we have marked in the previous slide equation number 3. This is the one. Okay. So from here we calculated 0 to pi by 2 log sine x. 2 we bought here, that is I by 2 will be coming. I1 value we have got. Actually I1 is only one part of our calculation. We have to go back and substitute. So putting this value of I1 in equation number 5. Equation number 5 is this one. We have calculated in the previous slide. I is equal to I1 minus pi by 2 log 2. So I1 value we have to substitute. That is I is equal to I1 value is I by 2. So we substituted I by 2 minus pi by 2 log 2. So I only we have to calculate. That means just from here onwards you can go with your own calculation. It's not a problem. LCM just I am multiplying. That is 2 into I 2i. Here when we multiply 2, that 2 and these 2 will be cancelled. So I will be there. Here also when we multiply 2, this 2 and the multiplied 2 will be cancelled. Only pi log 2 will be coming. This I we can bring to the left side. That is 2i minus I is equal to, right side there is minus pi log 2. So 2i minus I is I. So I is equal to minus pi log 2. So this is the answer. So we have explained this question, and what we have to do is in 3 different places you have to pause, and first up to equation number 3 and equation number next up to equation number 5 and then this one. Okay, 3 different places you just pause it and solve it, and after completing once again you try to solve by recalling the properties. Okay, move on to question number 17. Integral 0 to a root x by root x plus root of a minus x dx. So this question you will try it as homework. Next we shall discuss the 18th question, integral 0 to 4 mod x minus 1 dx. So this is a modulus function, so we know that how to solve this one. We have solved previously also. We will use the property splitting the limits, that property we are going to use. First of all, what we have to do is, let's take it as I is equal to integral 0 to 4 mod x minus 1 dx. Now we have to find out the splitting values here. For that, what we can do, that x minus 1 is there. So that x minus 1 we can equate with 0. X minus 1 equating with 0 means x will be equal to 1. So the splitting value is 1. So clearly 1 is between 0 and 4. So 0 less than 1 less than 4. So 0 to 1 will be one part, and another one will be 1 to 4. Then here when you take 0 to 1, this function will take the negative value, means less than 1. Minus of integral 0 to 1 x minus 1 dx, plus then next part, when it is greater than 1, it will take the positive value, that is integral 1 to 4 x minus 1 dx. Splitting this portion and all we have discussed in the previous class very clearly. Then minus of, this is quite non-format for us, we can do integration. So integral x is dx is x square by 2 minus integral 1 dx is x, then apply the limit, plus here also integral of x dx is x square by 2 minus integral 1 dx is x, apply the limit. Then minus of, here when we apply 1, that is 1 square is 1 by 2 minus, when we remove x and apply 1, that is minus 1 will be there, minus the lower limit is completely 0, so that full terms, both the terms will be 0, then we can write it as 0, plus here 4 square is 16 by 2 minus 4 into x is 4, minus the lower limit is, sorry, 4 into x is replaced and substitute 4, that is what it is coming here 4, okay. Then the lower limit, minus of 1, when we substitute 1 square is 1 by 2 minus x replace and put 1, that is minus 1. So there should be a bracket here because minus of the lower limit, okay, that is equal to, when we remove the bracket, minus 1 by 2 minus into minus plus 1, then 16 by 2 is 8 minus 4, then minus 1 by 2 minus into minus plus 1. Calculation as you wish, you can do it, it's not a problem. That is here 8 plus 1 is 9, 9 plus 1 is 10, 10 minus 4 is 6, 6 minus here minus 1 minus 1, that is minus 2 by 2. So the common denominator is there 2, so just to subtract the numerators, minus 1 is minus 2, addition we have done. So 2 by 2 is 1, so 6 minus 1, that is equal to 5. So simple question, just to try it. Next we shall discuss the 19th question. Show that integral 0 to a f of x into g of x dx is equal to 2 into integral 0 to f of x dx if f and g are defined as f of x is equal to f of a minus x and g of x plus g of a minus x is equal to 4. Two conditions are given and we have to show this one equal to this one, okay. So f of x is equal to f of a minus x, this is the first condition is given to us. Next is g of x plus g of a minus x is equal to 4, this is the second condition is given to us. And let's take the left hand side, integral 0 to a f of x gx dx is equal to I. Now when we check integral 0 to a, so the property we are going to use is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Quite familiar property for us because when we check exercise 7.11, most of the questions we have done by using this property, okay. So this equation we have marked as 3 and I is equal to integral 0 to a f of x, x is replaced with a minus x, so f of a minus x g of a minus x dx. So putting f of a minus x is equal to f of x from 1, so it is given condition f of a minus x is equal to f of x. So what we do, this one we can replace. So I is equal to integral 0 to a, this one we have replaced and substituted as f of x, and the rest is same, g of a minus x dx. Label it as equation number 4. Then adding equation number 3 and 4. Equation number 3 and 4, when we add I plus I is 2i is equal to integral 0 to a f of x gx. So here this part f of x gx plus f of x g of a minus x dx. So how we use this property and solve, the same way only we have done. So here equation number 1 and 2 we have marked by representing the given conditions. So it is easy to explain, that's why. or else this one 1 and 2 we can apply. It's not a problem. We have taken given a statement as a particular equation and we apply the property and we will mark it as another equation. Then we add these two equations. The algorithm, when you check, the same way only we are going. Then when we check here, f of x is there, here also f of x is there. So 0 to a, that particular f of x we can take common. F of x taken common means in this term f of x is outside, g of x is balanced. So g of x balance we can write. Plus in this term, in second term when we check, f of x is taken outside, balance is g of a minus x dx. You see this one, g of x plus g of a minus x, g of x plus g of a minus x is 4. That is, we can write it as 2I is equal to integral 0 to a f of x into 4 dx. That is by using equation number 2. Then here 4 is a constant that we can keep it outside, 4 into integral 0 to a f of x dx. So I is equal to, here you can see 2 and 4, when we cancel we will be getting 2. Okay, so I is equal to 2 into integral 0 to a f of x dx. This is what our right hand side. So hence the proof. Next we shall discuss the 20th question, that is the choose the correct answer questions, exercises 20 and 21. Question number 20, the value of integral minus pi by 2 to pi by 2 x cube plus x cos x plus tan power 5x plus 1 dx is. 4 options are there, 0, 2, pi and 1. Let's take this one as I is equal to minus pi by 2 to pi by 2 x cube plus x cos x plus tan power 5x plus 1 dx. So let's integrate separately. Integral minus pi by 2 to pi by 2 x cube dx plus integral minus pi by 2 pi by 2 x cos x dx plus integral minus pi by 2 to pi by 2 tan power 5x dx plus integral minus pi by 2 to pi by 2 1 dx. So here first of all we have to use a particular property, and the property is integral minus a to a f of x dx is equal to 0 if f is an odd function. So let's check which one is odd function here. Odd function means just clearly f of minus x is equal to minus f of x. Clearly x cube when you put, you can just check, okay, x cube when you put f of x, let's take f of x is equal to x cube. F of x is equal to x cube when you write, then we will go for calculating f of minus x. F of minus x when you put, what will come? Minus x is equal to minus x the whole cube. Minus x the whole cube means we will be getting as minus x cube. Minus x cube when we check, we can write it as minus x cube is f of x. So minus f of x we can write. So which one is the first one? First one is an odd function. Then again x cos x, if you take just f of x is equal to, we can go with x cos x. F of x is equal to x cos x. Then x cos x, after writing x cos x, f of minus x we will check. F of minus x when you check, what will be coming? That is equal to minus x cos of minus x. Cos of minus x. So here cos of minus x is cos x. So will be coming as again minus x cos x. Minus x cos x will be coming. Okay. So again minus x cos x means we can write minus f of x, because x cos x is f of x. So this is also an odd function, x cos x also. Similarly, tan raised to 5x when we check also, we will be getting as an odd function. The same way we can check. So here the first 3 are odd functions. First 3 are odd function means it is clearly f of x dx is equal to 0 we can write. So it will be coming as 0 plus 0 plus 0. This one you can check like this. Okay. Tan power 5 of minus x. So tan of minus x we can write it as minus tan x. Since the power is 5, the output also will be negative. So minus f of x will be coming. So first 3 odd functions we can write it as 0 plus 0 plus 0. Then only this one is left. Integral minus pi by 2 to pi by 2 1 dx. Very easy for us. Integral 1 dx is x minus pi by 2 to pi by 2. When we substitute here, upper limit minus lower limit, so replace x and put pi by 2. Pi by 2 minus lower limit is minus pi by 2. That means pi by 2 plus pi by 2. Pi by 2 plus pi by 2, when we do the calculation, we will be getting answer as pi. So the correct option is option C. Move on to the last question. The value of integral 0 to pi by 2 log 4 plus 3 sin x by 4 plus 3 cos x dx is 2, 3 by 4, 0, minus 2. So this question, correct option you have to find out as homework. Dear students, today we have completed exercise 7.11 and there are some difficult questions also there and lengthy problems as well, especially question number 16. So please mark such type of questions and revise and recall it separately in a sheet of paper while solving. If you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.